Let's revisit now the criteria for spontaneous activity. Let's start by writing the Gibbs equation. That's important that you write this thing many times because you're going to need that, as I'm not going to be provide equations in the exam. So delta G equals delta H minus T delta S. When delta G is smaller than 0, the reaction or the process is called a spontaneous process. Spontaneous process. It's also called a favorable process. Favorable. Or also called the exergonic process. This comes from Greek. It means work, and that's going to be generate free energy that's going to be able to do work. So this process here provides free energy available now to do work. In a cell, for example, some reaction are going to produce free energy, and this free energy is utilized to do other reaction that's not favorable. This reaction that are not favorable have a delta G larger than 0. It's called non-spontaneous. Non-spontaneous or unfavorable or endergonic. If you are going to take MCAT, this term might be important for you. And get inside, and the X put outside generate energy, and this one require energy. So for this one here, free energy is required. We also say sometimes that's driven by input of energy. So when we have a spontaneous reaction, it means that a reaction that once it starts, it can go by itself, doesn't need any external action to continue, as opposed to the non-spontaneous one that always requires an external action. For example, to make proteins from the amino acids, synthesis of protein is a non-spontaneous process. It requires energy all the time. If you don't provide this energy, the synthesis is not going to occur. As opposed to the spontaneous processes that goes and start producing and generating energy, and more, and it continues without any external force being necessary for the continuation of the process. Delta G equals 0, we say that the process is at equilibrium. One important aspect that we have to clarify today is that when you say that the process is spontaneous, that is going to occur naturally, but it doesn't say anything about the rate of the process. Whether this process is slow or it's going to be fast, there's nothing to do with the delta G. Saying delta G is smaller than 0, is spontaneous, doesn't say that it's going to be very fast. For example, one reaction, carbon exists in the form of diamond, in the form of graphite, and the delta G for this reaction is minus 2.9 kilojoule per mole. So is this a spontaneous reaction? Yes. Is this a fast reaction? Not at all. So we don't have to worry. A diamond is becoming graphite, but the reaction is so slow that we are not going to perceive any change in our lifetime because the reaction is very slow. The rate of the reaction is something completely different that will deal with that in the study of kinetics of the reaction. So there are catalysts, normally proteins, that are going to be utilized to speed up this reaction, whether the reaction is spontaneous or not. So the reaction in one way, in one direction being spontaneous, the reverse of that reaction is going to be non-spontaneous. And when we utilize enzymes, we are going to see that this enzyme speeds the reaction in the direction of spontaneous and non-spontaneous in both directions. So they don't affect much the equilibrium. Let's continue here to analyze a few cases. Let's go again and write the Gibbs equation. Delta G equal delta H minus T delta S. The more you write, the more you remember that. Let's take a case in here of delta H being smaller than 0. That's called the exothermic reaction that producing heat. And the delta is larger than 0. It's a reaction that is going to be increasing entropy, which is a very favorable process. It's an entropically favored reaction, for example. So in that case in here, if delta H is smaller than 0 and delta S is larger than 0, is a positive value, because of this here, this whole term on the right is going to be negative, right? So there is no other way for delta G to be, regardless of the values, delta G is going to be negative. Make sense? So delta G is going to be smaller than 0. It's going to be a spontaneous process. Process that generate heat and increase entropy is everything is favorable. So it's going to be a spontaneous process. Let's look at the other situation here. Delta H and delta G equal delta H minus T delta S. This time let's have delta H larger than 0, endotherm, and let's look now at delta S also larger than 0. Now let's do the smaller than 0 first. So this is a entropically unfavorable or opposed. So now we have delta S is negative and delta H is positive. So remember again about the sign here that's negative. So this whole term on the right in here, minus T delta S, is going to be positive, right? Because if this is negative and this is negative, the whole term is going to be positive, and we sum up with another term, delta H, that's positive. There's no other way, but this is going to be positive. So delta G in that case is larger than 0, is a non-spontaneous process or reaction. All right, so there are two other options. Let's examine these other two options. Delta H, again, delta G equal delta H minus T delta S. Now let's look at the case where delta H is smaller than 0 and the delta S is also smaller than 0. So delta H is smaller than 0 again is a exothermic reaction, and the delta S is smaller than 0. The entropy is decreasing, so it's a not favorable process. So this process here, we have now delta S is negative and the delta H is negative also. So what's going to happen here? This term here is going to be positive, right? This term here is going to be positive, but maybe the absolute value of this term positive may be not large enough to counter the negative value of delta H. So it all depends on the temperature. If the temperature here is high, this positive value is going to be very high, right? Because it's multiplied by a very large number of the temperature. So the delta G here might as well become larger than 0, non-spontaneous process. But when a situation like that, at lower temperature, the delta G, if the temperature is very low, this term minus T delta S may be so small that's not going to be able to counter the negative value of delta H. So these overall results might be smaller than 0. In a situation like that the entropy is not favorable, but the enthalpy is favorable, and yet the process is delta G smaller than 0, is spontaneous, we call that this is a process that's enthalpy driven. Enthalpy driven process or reaction. So the enthalpy prevails, but you see here that this is temperature dependent, correct? Depending on the temperature. This happens at a very low temperature. Finally, delta G equals delta H minus T delta S. Now we have left is that delta H is larger than 0 and delta S is also larger than 0, right? So in that case in here, we have now delta S positive, delta H positive. So what's going to happen here? Again, depends on the T because of this sign here. This whole term on the right is going to be negative because of this plus, but this is minus. It's going to be negative. How? The question is it going to be negative enough to counter the positive value of delta H or not? So there are two possible scenarios. If the temperature is very high, the delta G now is going to be negative, right? The temperature is very high. What's happening here is that this value is going to become a negative value, but a very high value, larger than the absolute value of the delta H, right? So that is going to be less than 0. It's a reaction here that the enthalpy is not favorable, but the entropy is favorable, and it became, at this temperature, it becomes a spontaneous process. We call that a entropy driven process. Okay, so it's an entropy driven process here, and if the temperature is very low, what's going to happen here? The negative value is very small, so the delta H is going to be larger, and therefore the delta H is positive, so this reaction is going to be positive. It's a non-spontaneous reaction. There is one case that's very intuitive that we can clarify now, is that the case of ice melt into water. What do you think here? What's this? Is this a spontaneous process or non-spontaneous process? Entropy is increasing or decreasing? Entropy is increasing, right? Because we know that in the solid state, the molecules are more organized, in the liquid is less organized, and in the gas phase, even less organized, right? So if we are going from ice, which is a solid state, to water, that's a liquid, then we are going to increase the delta S. So this is a delta S larger than 0. But this process here also, to melt ice, you need to heat it, right? You all know that. So this is an endothermic process, endothermic, so delta H is larger than 0, correct? So if you look at this reaction at, for example, let's say 10 Celsius, at 10 Celsius, and you calculate the delta G of this reaction at 10 Celsius, is going to be minus 220 joules per mole. Very small, but still there. Minus 20. So it's a spontaneous process at a high temperature, right? The ice melts easily at a high temperature. Now, if you look at this at minus 10 Celsius and calculate this thing, here the delta G is going to be 212. It's a positive value. I'm not going to put this plus sign there, but it's understandable that this is a positive value, right? So this is a delta G larger than 0 is a non-spontaneous process. At minus 10, ice doesn't melt spontaneously into water. At plus 10, it dies. And what happened at 0 Celsius? Delta G is going to be equal to 0, because this is the equilibrium. This is the temperature of a melting point of water. So at 0, the two sides are in equilibrium. So delta G is equals 0. I hope that clarifies the issue for you now. Thanks for watching.